In the previous video, we looked at how to evaluate the performance of clustering algorithms. In this video, we're going to take a look at automatically estimating the number of clusters using DBSCAN. As one of the input parameters, in the real world, we wouldn't have this information available. We can definitely sweep the parameter space to find out the optimal number of clusters using the silhouette coefficient score, but this would be an expensive process. Wouldn't it be nice if there were a method that can just tell us the number of clusters in our data? This is where density-based spatial clustering of applications with noise, DBSCAN, comes into the picture. This works by treating data points as groups of dense clusters. If a point belongs to a cluster, then there should be a lot of other points that belong to the same cluster. One of the parameters that we can control is the maximum distance of this point from other points. This is called epsilon. No two points in a given cluster should be further away than epsilon. You can learn more about it at staff.www.itn.liu.se. One of the main advantages of this method is that it can deal with outliers. If there are some points located alone in a low-density area, DBSCAN will detect these points as outliers as opposed to forcing them into a cluster. So let's move ahead and see how to go with it. The full code for this video is given in the estimateclusters.py file that's already provided to us. Let's look at how it's built. Create a new Python file and import the necessary packages. Then load the input data from the dataperf.txt file. This is the same file that we used in the previous video, which will help us compare the methods on the same dataset. So you can see here that we've inserted this code to load the input data. Now we need to find the best parameter. So let's initialize a few variables. First, let's sweep the parameter space. For each iteration, we need to extract the performance metric. So we perform the extraction here. Then we store the best score and its associated epsilon value. After this, we go on and plot the bar graph. Next, we store the best models and labels. Some data points may remain unassigned, so we need to identify them in this way. Now we extract the number of clusters. Also, we need to extract all core samples. Then let's visualize the resultant clusters. We will start by extracting the set of unique labels and specifying different markers. Let's iterate through the clusters and plot the data points using different markers. So you can see, we've done it here. Now let's run the code and see the output. So after running the code, you can see that we obtained the best epsilon value is 0.8, and the estimated number of clusters is 5. We also got the graph of silhouette score versus the epsilon. Also, let's look at the labelled data points along with unassigned data points marked by solid points in the second figure. Excellent! In this video, we have obtained the number of clusters in our data using the DBSCAN algorithm. In the next video, we'll find patterns in stock market data.